Good afternoon, and thank you for joining us for today's webinar, Chlorine, Chemical and Physical Properties and Emergency Response, brought to you by the Short-Line Safety Institute, the American Short-Line and Regional Railroad Association, and the Chlorine Institute. My name is Sabrina Weiss, and I'm the Vice President of Education and Business Development for the ASL-RRA. And before we begin, I want to let everyone know that we are recording this webinar, and we will make the recording available to participants on the website, so you may go back and review anything that's discussed today. To ensure quality audio for the recording, all attendees are on mute, and you will only be able to hear our presenter speaking. And our presenter will not be taking questions at the end of today's presentation. So if you have questions related to this topic, please visit the Chlorine Institute website at www.chlorineinstitute.org or email info, that's INFO, at CL2, that's CL the number 2.com. Okay, so I'd like to go ahead and introduce today's presenter. We are fortunate today to have one of the Chlorine Institute's ChlorEP leaders to share their experience with you. He will lead you through this fast-paced, information-rich webinar. Kevin O'Rourke has been in the chemical industry for 23 years. He is currently the operations manager for 4 facilities located in the St. Paul area in Minnesota for Hawkins Incorporated. One of those facilities is a chlorine packager and bleach manufacturing location. And besides riding his Harley and pretending to be Eric Clapton on his guitar in the basement, he also loves writing these bios about himself in the third person. So that gives you a little glimpse into his humor. Kevin is here with me now, so I'm going to go ahead and turn things over to him to get us started. Welcome, Kevin.
Hey, everybody. So let's talk about the objectives of today's webinar. We got several goals we'd like to accomplish with this presentation. The first of which, we would like you to let our attendees know a little bit about TransCare, the Chlorine Institute, and ChlorEP. However, our main goal is to provide you with important information about chlorine chemical and physical properties and, of course, chlorine emergency response. We will provide an overview of the chemical, its uses, its physical and chemical properties, and the health and environmental hazards that may be encountered. We'll provide an understanding of how the properties of chlorine will affect emergency response actions, the treatment of exposures, and security concerns. For example, many first responders' first instinct may be to apply water to a release from a leaking chlorine container. However, doing that can actually make the situation worse. So since this webinar is hosted in partnership with the Short-Line Safety Institute, we will describe the various chlorine transportation and storage containers, but our focus will really be on the containment kit for tank cars and how it can be used to mitigate a leak, if other methods, like closing valves, are not successful. And finally, we'll provide an overview of the resources that are available before and during an emergency. Important thing to remember is that you are not alone in responding to a chlorine incident. There are many resources out here that are available to help you. So first, let's talk about what TransCare is. TransCare stands for the Transportation Community Awareness and Emergency Response. It's a voluntary outreach effort in the U.S. and Canada to help communities prepare and respond to possible hazardous material transportation incidents. It was established in 1986 by members of the American Chemistry Council, the Chlorine Institute, and Class I railroads and other transportation partners. TransCare accomplishes its mission by, first, providing training in local communities for first responders and hazmat specialists, developing and maintaining a library of training materials, and then partnering with railroads, chemical producers, distributors and users, tank truck industry, government, and other stakeholder groups to provide knowledgeable and experienced hazmat instructors. If you want to learn more about TransCare and the many resources that are available to you, you can visit them online at transcare.com in the U.S. or transcare.ca in Canada. So what is the Chlorine Institute? Well, established in 1924, the Chlorine Institute is a nonprofit technical trade association that represents about 195 companies worldwide that safely produce, distribute, and use chlorine, sodium and potassium hydroxides, and sodium hypochlorite, distribute and use hydrogen chloride, and distribute vinyl chloride. Because chlorine is so widely transported and used, it has long been an accepted responsibility of the producers, packagers, and distributors of chlorine and the users to promote chlorine safe handling, secure transportation, and effective emergency response methods to protect not only the public health, but the environment. The Chlorine Institute, or CI as we call it, is the focal point for fulfilling these responsibilities. CI accomplishes its mission by maintaining the chlorine emergency plan, which we call CHLOREP, developing technical and safety-related publications for chemical safe handling, providing training workshops and videos for its members as well as end users of chlorine and emergency responders, and working with various government agencies to advance our shared objectives for improved chemical safety and security. So what's CHLOREP? Well, CHLOREP is short for the Chemical Emergency Plan. Established in 1972 by the Chlorine Institute, is the industry's 24/7 emergency response mutual aid program. It's supported by chlorine producers, packagers, and specially trained emergency response contractors. CHLOREP provides support for chlorine emergencies in the U.S. and Canada by ensuring that transportation service providers, end users, first responders, and hazmat teams, and others have ready access to accurate information and expert industry resources. CHLOREP's member response teams and emergency response contractors can provide critical support via telephone within minutes. And when needed, they can deploy emergency equipment and personnel to the scene of an incident in an efficient manner. So the CHLOREP mission, we accomplish it two ways. First, through training, like today's webinar, to assure effective emergency response preparedness, prevention, and mitigation of any chlorine incidents. And second, through the maintenance of the CHLOREP Emergency Response Mutual Aid Network to ensure a timely and professional response to all chlorine incidents. Through CHLOREP Emergency Responses Mutual Aid Network, the industry is able to effectively respond to state and local requests for assistance. A 24/7 emergency response mutual aid network that is supported by 90 response teams from 25 member companies that produce and package chlorine, as well as 8 chlorine emergency response contractors that meet stringent industry performance requirements. So this map here shows the 21 geographic sectors or regions which provide complete coverage across the U.S. and Canada for the different CHLOREP teams. Looking at it, for instance, I'm based out of St. Paul, Minnesota. You'll see I'm a member of CHLOREP Team 11. But in each area has their own chlorine response teams that can respond to an incident. So how do you activate the CHLOREP team when there's an incident? It's pretty easy. In the U.S., a single call to Chemtrec, the chemical industry's 24/7 transportation emergency center, will provide a direct link to a CHLOREP response team in that sector. In Canada, it works a bit differently. In that case, a single call to Canutech will put you in touch with a chlorine supplier or shipper who has the ability to activate CHLOREP through its emergency response assistance plan, or what Canada calls an ERAP. Although initially set up to deal with transportation emergencies, these 24/7 call centers can provide assistance for any chlorine emergency. So let's move on to the next part of the webinar. Enough explaining who we are and what where we originated from. But let's talk about the chemical and physical properties of chlorine. Chlorine is an essential chemical used in the manufacture of thousands of everyday products and to keep our environment safe and disease-free, such as disinfecting our drinking water. It's used in the production of 93% of the top-selling medicines out there. It's the leading disinfectant in homes, hospitals, healthcare, daycare facilities, restaurants, and more. It's used in agriculture to produce 86% of the chemicals that protect our crops. Chlorine is used in the production of many types of plastic materials we take for granted every day, and it's used in the renewable, clean energy, and recycling industries. It's estimated that about 40% of all industries use chlorine directly in their operations, but virtually every industry uses chlorine indirectly. You can see that because chlorine is so essential to our lives, it's no surprise that chlorine is also one of the most commonly transported chemicals throughout our communities. So the need for an effective rapid emergency response network is critically important. This pie chart shows the major uses of chlorine. You can see that the vast majority of chlorine is used in industry to make other products. And industry does a good job of producing, shipping, and handling chlorine safely. Having said that, it's worth noting that the 4% of chlorine that goes into disinfection, which is largely drinking water and wastewater treatment, is the area where we tend to see the most incidents. There are a lot of small facilities that use smaller containers, like a 150-pound cylinder or a ton container of chlorine. That's important to know from a preparedness point of view because it's far more likely that a first responder would have to deal with a cylinder or a ton container leak in their career than they would ever have to deal with a tank car or a highway cargo tank leak. You may think that there are some similarities between chlorine and bleach. And in fact, you may have heard bleach referred to as chlorine bleach or liquid chlorine. but it's critical that you understand that while chlorine is used as a raw material to produce bleach, bleach is not chlorine. First off, they're plaque prorated differently. The US DOT classifies chlorine as a Division 2.3 poison inhalation hazard gas and bleach as a Class 8 corrosive, which have very different characteristics and hazards. One of the first things you'll need to assess upon arriving at an incident is the chemical involved, which will dictate what type of response plan you need to activate. This is especially important when it comes to personal protective equipment, which we'll review PPE in more detail later on in the webinar. Chlorine has a very strong, pungent, bleach-like odor, and it's got a low odor threshold, around 0.2 to 0.4 parts per million. I mean, it doesn't take very much to let you know that that is chlorine present. Chlorine is shipped as a compressed liquefied gas. The only time it arrives at a customer's facility in gaseous form is when it is directly pipelined from a producing facility. Household bleach is always an aqueous solution. Remember that chlorine bleach is not liquid chlorine. You'll hear people call it that, and it's not. So, chlorine properties. The liquid chlorine has a clear amber color. It's 1.5 times heavier than water. One important fact to keep in mind about chlorine, and this will come into play during rescue and first aid treatment, is that liquid chlorine is a very, very cold substance. Its freezing point is minus 150 degrees Fahrenheit, and its boiling point, or the point at which it becomes a gas, is minus 29 degrees Fahrenheit. So compressed liquefied chlorine gas will quickly cool to this boiling point once it reaches atmospheric pressure, when the container is open or punctured. This phenomenon is known as auto refrigeration, which is typically made evident by a visible frost line that occurs on the punctured container. We'll talk a little bit more about auto refrigeration in detail later. Liquid chlorine has a very high coefficient of expansion, meaning it only takes a little bit of the liquid to make a lot of gas. Weather and temperature, of course, may affect this equation, but a good rule of thumb is that 1 volume of liquid chlorine will expand to about 460 volumes of chlorine gas. Chlorine exhibits a vapor pressure at temperatures above its boiling point. In other words, whenever the temperature gets above minus 29 degrees Fahrenheit, the resulting gas begins to create pressure, and this pressure will increase rapidly as temperature increases. So we're going to show you a little video here. This is actually liquid chlorine that's in a beaker inside a lab. And notice how the vapor stays in the beaker when this boils here. It doesn't react the same way that a boiling pot of liquid does. The steam rises and comes out of a boiling pot of liquid, where in that container, you notice that all the chlorine gas stayed inside the beaker. There was that yellowish haze that you can see. The thing to remember is that chlorine vapor is heavier than air, so it wants to go down low. It doesn't want to rise like water vapor does. So chlorine exhibits that faint yellowish color at low concentrations that you could see in that beaker. But it will be yellow or green yellow at high concentrations. It's 2.5 times heavier than air, meaning the chlorine gas has a tendency to settle in low-lying areas like ravines and trenches and toward the floor inside a building. Chlorine gas is typically not visible below about 25 parts per million. That's dependent on humidity though. But remember, it has a very low odor threshold of about 0.2 to 0.4 parts per million, so you may smell it well before you see it under certain conditions. Chlorine gas has a direct pressure and temperature relationship, meaning that as the temperature rises, so does the pressure. This is critical knowledge when you come upon a leaking chlorine container. Your first instinct may be to put water on the container, but think about what you're actually doing here. The water coming out of a hose is about 60 degrees Fahrenheit. When you apply water to a container that has the liquid chlorine inside it, which has a boiling point of minus 29, you're actually raising the temperature of the material inside. And when you raise the temperature of the chlorine, you're raising the vapor pressure and potentially making the conditions worse, increasing the pressure inside the container and causing more to escape. It is acceptable to cool and overheat a container that is sealed and then not leaking. It's never a good idea to spray water directly on a leak, because water and chlorine can combine to be very corrosive to steel, and you could actually make the leak worse. So mixing water and chlorine also produces hydrochloric acid, which introduces additional issues to the situation. So chlorine reacts violently with greases, oils, and solvents. This slide shows some common substances that will cause a violent reaction when chlorine comes into them. And this next slide here, we're going to show you a video where the chlorine comes in contact with a rag that has some oil on it. And you see the black smoke start to develop and the rag is starting to turn black. The chlorine is actually causing that rag to burn. It's burning very slowly, and as it continues, you can start to see the red ember glow happen in the middle of the rag there. So the chlorine is reacting with the organic material there and actually causing it to start on fire. Chlorine is also highly reactive with other certain materials. Wet chlorine, for instance, is very reactive and corrosive to most metals. Dry chlorine is compatible with most metals except titanium, aluminum, and tin. Chlorine reacts violently with steel at temperatures above 450 degrees Fahrenheit, and it can even support combustion at about 480 degrees Fahrenheit. These are all facts you should keep in mind when responding to a chlorine incident where fire is involved. And to show that, here's an example of a piece of steel wool that it comes in contact with chlorine inside the beaker. Quite a lot more smoke and a lot more fast reaction than there was with the oily rag. Okay, we talked about auto refrigeration a little while ago, and this video is going to explain auto refrigeration in more detail. So we'll let you listen to this.
The chlorine in a cylinder, ton container, tank car, or cargo tank is a liquefied gas under pressure. The temperature of that liquefied gas is cool, but not so cold that the exterior of the container would be cold to the touch. At higher pressures, liquids boil at higher temperatures. At lower pressures, liquids boil at lower temperatures. This is why water boils at lower temperatures at higher elevations above sea level. The atmospheric pressure is lower, so the boiling point is lower. When a chlorine container is punctured, allowing the chlorine to release, at first the chlorine will escape rapidly. As the chlorine is released, the container that was under pressure will now equalize in pressure with the atmosphere. Once the liquid level drains below the puncture point, auto refrigeration takes place. Auto refrigeration is the result of chlorine quickly escaping from the container, which causes the chlorine to cool down below its boiling point at the new lower pressure condition. It becomes colder because it is no longer under pressure from being in an enclosed container. Because the chlorine remaining in the container is so cold, a visible frost layer will form on the outside of the container at the liquid line, which is typically the level of the puncture. When this occurs, the rate of release will significantly decrease, although there still is a considerable amount of liquid chlorine remaining in the container. However, any heat source, like water, or agitation, like moving the container to a secure location, can cause the remaining liquid chlorine to vaporize and allow more vapor chlorine to escape.
So in this video, we're going to watch a short video that shows the release of 1 ton of chlorine that was conducted by DHS out in Dugway, Utah. This tank is situated in a shallow basin, and we'll watch the first minute, which is all it takes for the liquid chlorine to be expelled from the bottom of the tank. And then we'll see the glass cloud at 5 minutes after release, 10 minutes, and 30 minutes into the release. So right now there's 1 ton of liquid chlorine being released from a 2-inch valve in the bottom of the tank. You can see the immediate flashing of the chlorine vapor. We already talked about the low boiling point of chlorine, so you can see the liquid spraying at a fairly high pressure from the valve. The chlorine stays fairly low to the ground and dissipates slowly in the direction of the wind. So we're right about at the 1 minute mark now, and you can see that the amount of chlorine coming out of the container is significantly reduced. And here we are about 5 minutes in after the start of the release. Only 4 minutes after that tank emptied. You can still see the cloud, but it's gotten much smaller. You can see the remains in the lower area of the basin. And now another wipe and we're at the 10-minute mark. You can see it's dissipated quite a bit over the last 5 minutes, but there's still quite a bit of color left in the basin. And then we just hit the 30-minute mark right there, and you can no longer see any chlorine in the area. That does not mean it's safe to approach, though, without respiratory protection. But it does show that chlorine gas clouds begin to dissipate soon after the release is stopped. So that should be our first priority, stopping the release. We're going to see another video here. And in this video, we're going to show you chlorine on the left over here and ammonia on the right. Both are parts of the jackrabbit release. But it's going to show the difference in the behavior of the gases, one which is heavier than air, chlorine, and one that's lighter than air, the ammonia. You can see that although the chlorine does rise a little bit on the left, it doesn't rise anywhere near as high as the ammonia on the right, which is about half as dense as air, whereas chlorine is 2.5 times heavier than air. I guess to the point here where you can barely even see the tank from the ammonia release. It becomes obscured by the cloud of ammonia vapor, whereas you can see on the chlorine on the left, the chlorine vapor all stays down close to the ground, and you can still clearly see the tank. You can also see that the plume of material is a lot tighter and stays around the tank tighter than the ammonia does. The ammonia has spread quite a lot farther. Okay, so our primary concern in emergency is always the protection of human life. So let's talk about the health effects of chlorine. Chlorine is a toxic gas and primarily a respiratory tract and eye irritant. It's also corrosive. Getting it on your skin can cause chemical burns. Being a strong oxidizer, there's a risk of heat-related burns if the chlorine becomes reactive. And remember that whenever you see liquid chlorine, it's going to be very, very cold. So there is a risk of thermal burns or frostbite from exposure to the liquid chlorine. But chlorine also has a very low odor threshold, about 0.2 to 0.4 parts per million for an average person with normal respiratory health. So it has an effective built-in early detection system. We are primarily concerned with respiratory system exposure followed by eye exposure. What is that? Remember that when chlorine comes into contact with water, hydrochloric acid may be formed. And our bodies are made of mostly water. If enough chlorine gets into the nose, throat, lungs, and the mucous membrane, hydrochloric acid will begin to form, and that's extremely corrosive to human tissue. The impact of any exposure is dependent on the concentration of the chlorine and the length of the time the person is exposed to the chlorine. So here are the official exposure limits for chlorine. It's important to note that chlorine is not considered a carcinogen. In fact, except in lethal doses, most people exposed to chlorine have received prompt treatment will fully recover. You can see from this chart that it does not take a lot of chlorine to cause serious injury to health. At about 30 parts per million, serious adverse effects begin to occur. But again, the odor detection limit, the early warning at 0.2 to 0.4 parts per million is well below the limits that would affect health. Unless someone is suddenly overcome or is unconscious, they should begin to smell it, and that should tell them to be able to take protective action. Let's talk about treatment of exposures, and specifically we'll talk about inhalation first. You must always wear proper PPE, which includes an SCBA and protective clothing. When you come across a victim who has an inhalation exposure to chlorine, move them to fresh air as quickly as possible. For minimal exposure, there is no specific treatment other than to get them out to fresh air and away from potential re-exposure due to shifting weather. At low-dose exposures, victims will usually begin to be symptom-free within an hour, but chlorine does have a delayed effect. Victims should still receive medical attention regardless of exposure amount and should be monitored for several days. For a more significant exposure, as evidenced by chest tightness or dyspnea, persistent cough, and anxiety, oxygen therapy and other supportive measures are required. Move the victim to fresh air and get immediate medical attention. Monitor for respiratory distress. Emergency airway support due to possible swelling may be necessary as well, as 100% humidified supplemental oxygen with artificial respiration. Here is where you will want to use water. Make sure you remove contaminated clothing and flush skin with plenty of water. Transfer the victim to a hospital or nearest emergency medical facility. If chlorine has come in contact with the skin, wash their skin with plenty of water immediately for at least 15 minutes. Remove any contaminated clothing and flush the skin with water. However, remember that chlorine is very cold and the victim may have thermal burns. If liquid chlorine is splashed on the clothing may freeze to the skin. Removal of their clothes may remove frozen skin. Be very careful and use plenty of water first and get medical attention immediately. If the eyes have been exposed to chlorine, wash the eyes with large amounts of room temperature water for at least 15 minutes. Use an eye wash station if it's nearby and in a safe area. Lift the lower and upper eyelids to make sure that all the chlorine gets flushed out and get medical attention immediately. An ophthalmologist should examine the victim after contact. If the victim is wearing contact lenses, remove the lenses after 5 minutes of water flushing and then continue flushing the eyes for an additional 10 to 15 minutes. Chlorine is a naturally occurring element which is only found in nature in combinations with other elements. Again, chlorine mixes with water, hydrochloric acid may form. This is important to keep in mind during your response. Your first inclination may be to put water in a leaking container. And as we discussed earlier, this raises the temperature of the gas, which raises the pressure. Also, by putting water on the chlorine source, you are probably creating hydrochloric acid, which can run off into the surrounding areas, waterways, and storm drains, and creates its own environmental concern. Furthermore, it's extremely corrosive to the steel that's used to make the chlorine container, and it can take a small leak into a big leak very rapidly because it's corrosive to the steel. When you approach a scene, there may be environmental cues that you can use to determine if chlorine has been released. Leafy plants like trees and grass, chlorine can cause bleach spots or burns. The inhalation effects on animals are similar to those on humans, so dead animals at the scene may indicate chlorine is present. Very low concentrations of chlorine in water adversely affect aquatic life. The DOT lists chlorine as a marine pollutant. So again, it's critical that you try to keep chlorine in any water you may have used near chlorine out of storm drains and waterways. All right, so that pretty much covers physical properties and first aid. We're going to talk about what to do for an emergency response now. So these are the various containers that we use to transport chlorine. Chlorine is shipped in 100 and 150-pound cylinders, which are up in the right corner there. 1-ton containers and 22-ton highway cargo tanks, which are on the bottom. And then finally the 90-ton tank rail car, which is what we're going to focus on primarily. The worst case scenario would be involving the puncture of a chlorine container resulting in the sudden release of its contents. Those types of incidents require the skilled expertise of a ChlorRep response team or a ChlorRep contractor to secure the container and properly manage the remaining risks. Fortunately, based on historical performance, the probability of those incidents is really low. The most common types of emergencies involving chlorine containers involve much smaller releases associated with the valves and the gaskets or pinhole leaks on the container. In the next several slides, we'll talk about potential leak points for the various types of chlorine containers and what first responders can do to mitigate those leaks. All right, so here we have a little video that shows a method to look for a leak. It can sometimes be really difficult to pinpoint the exact source of the leak, so we recommend using a plastic squeeze bottle containing about a 10 to 30% solution of aqua ammonia to check for them. As shown in this video, direct vapors from the chlorine squeeze bottle, and let me get there, will produce that white cloud that you can see. Be careful not to squirt the liquid out of the squeeze bottle because it can react with the chlorine and become corrosive to the container, potentially making the leak worse. This method can be used to detect chlorine leaks from any of the containers used in this webinar. So again, you want to get the squeeze bottle to be vapor, and the vapor, you can see it reacting with the chlorine leak there, and it makes that white smoky cloud. That's where you can determine where your leak is coming from. Larger bulk quantities of chlorine are always shipped by rail in 90-ton rail tank cars. Tank cars are special purpose DOT specification 105J500W, 105J600W, and 105J600I. The cars are jacketed and insulated. These cars have no bottom outlets, and the tank cars are constructed of unlined carbon steel that is about 3/4 to an inch thick. They typically contain about 14,700 gallons, or about 180,000 pounds of chlorine when they're full. A loaded tank car will at most contain 90 tons of chlorine, which equates to about 80 to 90% liquid full, depending on the temperature. A loaded car typically has an internal pressure between 50 and 120 psig, and the product temperature is typically between 50 and 80 degrees. After the chlorine car has been unloaded, the tank car will contain residual amounts of chlorine, referred to as a residue tank car. There can be as much as 2,500 pounds of chlorine still in that tank car in a mix of vapor and liquid. You can routinely see pressures in a residue tank car that are between 150 and 275 psig if the tank car has traveled through hotter climates for a long period of time. This is particularly likely if a customer used pad pressure, an air or inert gas, to assist in their unloading operations, and they did not reduce the internal pressure prior to shipping the residue tank car. This slide shows the most common chlorine valve arrangement found on cars. The valve arrangement inside the protective housing of both tank cars and tank trucks are identical. There are 2 liquid valves, which are attached to dip tubes that run straight down inside the tank to the bottom, and 2 vapor valves, which provide access to the vapor space above the liquid. The liquid valves will always be oriented lengthwise with the tank. This is to allow the dip tubes to be submerged in as much liquid as possible. For this valve arrangement, liquid valves also have an excess flow check valve located below them, which will flow anywhere between 7,000 and 32,000 pounds of product per hour per valve, depending on the valve's design. The vapor valves will always run perpendicular to the length of the tank. The component in the center of the valves is the car's pressure relief device, or PRD. This is necessary to relieve elevated pressure from inside the tank. The PRD for chlorine tank cars is set at 375 psig. It should be noted that the chlorine tank cars are typically shipped with a security seal placed on the car's closed protective housing or dome lid. If the security seal has to be removed, write down the number of the seal and try to document who removed it or why it was missing before going any further. This slide shows the typical leak points on a chlorine tank car valve. So that's a cutaway of the valve right there. Typical leak points include this packing nut at the top, the valve seating surface, the gasket where it hits the manway of the tank car, and then the valve outlet. This is an older style of PRD. This slide shows the typical leak points of that. If possible, always check the pressure of the car to assess why the PRD is leaking or releasing. Be sure to confirm the reason for the leak before installing a capping kit. The reasons for excessive pressure could include the tank has been overfilled, the tank has experienced damage due to impact, and there could be excessive heat impingement on the tank, or there could be internal contamination of the tank of chlorine. Here's another typical PRD. This is the Midland pressure relief device. You can see the telltale valve on the side of the device over there. And this shows that same Midland PRD with the dust cap removed and the valve cut away, so you can see the internal workings of that relief. Unfortunately, the kind of potential leak points shown in the photo can be some of the most difficult to mitigate right here. The only way to stop this is to tighten all 20 bolts down in a crisscross pattern if it's leaking between the manway and the tank nozzle. You may require a mechanical advantage such as a torque multiplier. If the leak cannot be stopped, you must contain the vapors and arrange to transload the car. It is recommended that these types of leaks are handled by well-trained and experienced chlorine emergency responders. This is the Chlorine Institute's Emergency Kit C, which contains all the tools you need to address the leak points we all just discussed. However, a word of caution is appropriate. Use of the C kit is a last resort. Always check the pressure in the tank car or the cargo tank to determine that the tank is not liquid full or under high pressure before applying a capping kit. Understand what's going on inside the car before you try to stop a leak. Then, always try to stop the leak without applying a capping hood. See what you can tighten before applying the hood. If a leak cannot be stopped by tightening the valve or fasteners, check the pressure again to verify that the car is still not liquid full or under high pressure before applying the capping kit, hood, or to a valve or PRD. C-kits should never be installed on PRDs when they are releasing product, as they are designed to do conditions I previously mentioned. It should be only applied if the PRD is malfunctioning and will not stop releasing. Once a capping kit hood is applied, the tank car will no longer be authorized to move without a one-time movement approval from the Federal Railroad Administration, an agency within the DOT. Approval is most often requested by the railroad or the tank car suppliers. So the next video here is going to show you how to actually install the C-kit on a rail car.
Device 6 can be used to contain all leaks in and around the angle valve. Remove the outlet cap from the vent valve on the hood and open the valve. Unscrew the valve outlet plug. Place the outlet plug against the packing gland. Use the paint scraper C2 if the paint is loose or uneven. Place hood 6A1 with the gasket 6B and V over the leaking valve. Place the yoke assembly 11A hooks into the port openings of the protective housing or to the mounting bars inside the housing if provided. Center screw over the hood 6A1. Tighten screw forcing hood and gasket against the pressure plate. In an alternating pattern, tighten the 4 screws using wrench 200C, forcing hood and gasket against the pressure plate. Close vent valve on the hood using wrench 200C. Replace the vent valve outlet cap. Test for leaks immediately after installation and at regular intervals.
Okay, so this video is available, the full video, because we're only showing a small part of it here, is available for free on YouTube. You can just Google Chlorine C-Kit installation and you can find it, or you can get it from the Chlorine Institute bookstore. Another tool that's available for use by emergency responders is the Midland Emergency Response Kit. It has a universal design that can be used to mitigate valve leaks on tank cars and cargo tanks of many different types of pressurized cargo, including materials like chlorine, vinyl chloride, LPG gas, and anhydrous ammonia. The contents of that kit are shown here on this slide. And we're going to show you, the next slide is that Midland kit installed on a chlorine tank car, showing you how it would be installed if it was going over the pressure relief device in the middle of the car. There's another manufacturer out there called Kelso, who makes a kit, and it can also be used to mitigate valve leaks on tank cars and cargo tanks for many different types of compressed gas tank car valves and fittings also. The contents of that kit are shown in this slide. So if I want to find out more about any of those kits, you can just contact one of the manufacturers shown on this slide. These companies are all members of the Chlorine Institute and would be very pleased to work with you. Let's talk about a case study here for a chloride response to a rail incident. This one involves a leaking chlorine tank car. The initial assessment determined that there was a leak in the manway gasket, where the pressure plate attaches to the nozzle of the tank car. First responders attempted to use a tool in the standard chlorine kit, emergency kit C, to tighten the nuts on the pressure plate, but they didn't have any luck stopping the leak that way. So they called Chemtrek to advise to activate the ChlorRep network, and a ChlorRep response team was promptly dispatched to the scene, where they were able to transload the remaining chlorine from the tank car in the field. After unloading the tank car, it was then removed to a tank car facility where the faulty manway gasket could be replaced. Large chlorine tank car incidents are rare, but they can be significant. We're going to take a look at 2 well-known chlorine incidents that have occurred. First one is Graniteville, South Carolina. Here are photos from January 2nd, 2005 derailment in Graniteville, South Carolina, which resulted in a chlorine release. A rail switch at the local mill track was not switched back to the main line, so a moving train on the main line turned into the mill and struck the parked train at the mill, resulting in a punctured chlorine car, releasing approximately 60 tons of chlorine. There were 9 fatalities, and 554 people were treated at a hospital and 75 were admitted. There were 5,400 people evacuated due to this incident. Here's photos from Festus, Missouri on August 14, 2002, where a chlorine release occurred when there was a rupture in the transfer hose at the tank car unloading facility. While unloading the chlorine tank car, the transfer hose ruptured due to incompatible material of construction. The operators activated the emergency shutdown, but the emergency shutoff valves did not close due to a corrosion buildup. The release lasted for 3 hours until the fire department manually closed the valves and resulted in approximately 24 tons of chlorine being released. 63 people were treated at the hospital and 3 were admitted. The community had to shelter in place for 4 hours, and the interstate was shut down for an hour and a half due to this incident. One thing first responders need to keep in mind, you're not alone when it comes to chlorine emergency. There are numerous resources available to help you when you're on the scene. The safety data sheets, or SDS for chlorine, will provide a wealth of information about the chemical and the recommended response measures. You can call Chemcheck or Canutech, who will help you with the information and connect you with appropriate resources. They can also activate Chloride. Look for company names and emergency contact phone numbers on the transportation container. By law, we must provide an emergency contact number with the transportation container. So if a container is damaged to the point where the number is obscured, just call Chemcheck. You should keep that number handy, or better yet, memorize it. Of course, the first priority when responding to an emergency is to protect life. But after assessing the incident, the focus should be on stopping the leak and containing the remaining product until it can be safely disposed of or transferred. Your first instinct may be to throw lots of water at the leak point, but as I've mentioned earlier, this could actually make matters worse. Chlorine and water can mix to produce the hydrochloric acid, which we've discussed is very hazardous to humans and the environment. And remember, the pressure-temperature relationship. Water on a chlorine vessel will raise the product's temperature, which will raise the pressure. Do not apply water unless there is a danger of fire impingement. Proper PPE must be worn at all times. Remember that the IDLH, or the immediately dangerous to life and health value for chlorine, is 10 parts per million. And the visibility threshold is 25 to 60 parts per million, depending on humidity. So if you can see it, you need to be in gear that is approved for use in an IDLH environment. Chlorine Institute Pamphlet 65 describes in detail the approved level of chlorine protective clothing and personal protective equipment necessary to safely respond to a chlorine incident. But before any response can be launched, there are certain criteria that must be met to ensure that proper PPE is being used and responders' lives are not compromised. First, the substance involved must be identified as chlorine and no other chemicals are involved. Knowledge of the emergency response guidelines for chlorine is essential to help anticipate health effects caused by exposure. Employees at a fixed facility should be trained and experienced in chlorine containment. The site safety plan should be assessed, and the incident command should be on site and in charge. Ultimately, the incident commanders who will dictate what level of PPE is necessary for a response. The level of chlorine protective clothing and personal protective equipment required when responding to a chlorine incident will be dictated by what kind of leak is occurring. Is it a gas or is it a liquid leak? For a gas release, proper PPE includes a level B with self-sealing suit or chemical tape securing the openings for the hands and the feet with a full face piece SCBA. Please note that this is not qualified for confined spaces where an even higher level of protection is required. For a liquid release or inside a confined space, proper PPE includes enhanced level B with a full face SCBA, a chemical protective suit, footwear cover, and a hood for neck and head protection, and thermal underwear to protect against chlorine's extreme cold. The primary objective of any response is to protect the public from harm. Protective actions can only be initiated after the isolation perimeter is established and the hazard control zones are defined. The natural instinct is to rush in, be the hero, and save the victim. That has to be avoided. You could do more harm than good to yourself, your team, and the public. There are several tactical options for safeguarding the public, including notifications, evacuation, shelter in place, or a combination of any of those actions. They are not mutually exclusive and will be dictated by conditions on the scene. The conditions will be assessed periodically to determine if protective actions need to be revised. Keep in mind, there will most likely be no clear criteria, but a variety of a lot of gray areas when it comes to public safety decisions. The incident command typically takes the lead in determining the appropriate actions based on the conditions and the expert advice available. This slide is the emergency response guidebook that can be an extremely valuable resource in an emergency. The ERG is issued by the US DOT and it's provided for free. As a first responder, you should have a hard copy or a smartphone app of the ERG readily available at all times. Just be reminded, however, that the protective action distance in the ERG are protective action distances, not evacuation distances. One form of protective action that can save a lot of lives in an emergency is shelter in place. But sheltering in place for a natural disaster like a tornado can be a lot different than sheltering in place for a chemical emergency involving heavier than air commodity like chlorine. This video will help you understand why.
Since chlorine is heavier than air and will settle in low-lying areas, people should move to upper floors if possible. Do not go to the basement. In many communities, especially in the tornado-prone Midwest, the general public has been trained to move to underground shelters or basements in an emergency. This is the exact opposite of what should be done during a chlorine release, as chlorine gas may find its way into basements. Move upstairs or to higher floors if possible. However, do not move to an attic. While attics may be the highest level in a house, they are typically vented in such a manner that they cannot be effectively sealed with duct tape and sheeting. These may include ridge vents, gable vents, and exhaust vents. In order to help prevent a gas cloud from seeping into the structure, quickly close all doors and windows and seal them with duct tape and plastic sheeting. From the inside, jam wet towels on exterior door bottoms and thresholds. Turn off any air conditioning, heating systems, whole house fans, and bathroom exhaust fans. The public may think that running an exhaust fan may help expel any chlorine gas that may have entered the premises, but this could actually create a vacuum or chimney effect, drawing in the chlorine gas. For maximum protection, shelter-in-place occupants should go to a windowless room, such as an interior bathroom. It's critical that occupants stay connected to first responders, so they need to take a means of communication with them into the safe room: cell phone, telephone, walkie-talkie, CB, or radio. Shelter-in-place occupants must remain in place and wait for instructions. They need to wait for rescuers to come to them. They cannot assume it's safe to emerge until instructed to do so. Finally, practicing home emergency drills is always recommended so occupants know what to do in case of a fire or weather-related emergency, and a chlorine emergency is no different. Occupants should discuss, plan, and practice the actions they'll take in the event of an incident.
So, accidents can and will happen, but we also need to recognize that an incident may be the result of an intentional act. Especially considering today's 9/11 and the anniversary, we need to be aware that there could be issues that were caused from a terrorist activity. So, as responders, part of the responsibility of assessing the situation includes being observant about security. Security in an incident involves two general tasks. Basically, immediately control of the situation to promote the mitigation of the incident, establishing zones and perimeters, limiting entry into the incident site, and establishing general alarms and hand signals and proper notification of emergency contacts in hospitals. All with a mindset that the incident may have been the result of a criminal act, anything from vandalism to terrorism. Evidence preservation and awareness of suspicious surroundings, objects, vehicles, and behaviors is all important. Be observant and report your findings to the proper authorities. It's important for you to have as much upfront knowledge as possible about hazmat incidents and response before the condition incident occurs. The more you know ahead of time, the better you'll be able to respond and protect your team and the public. Fortunately, there are many information resources available to you. This includes personal network and getting free hazmat training through your community through TransCare and the Chlorine Institute. The next slide shows us some of the chlorine training opportunities that will be available through the U.S. and Canada in 2017. In addition, CI's website is full of valuable information, including pamphlets, checklists, and guidelines and safety training videos. The more time you can devote to pre-incident education, the better off you'll be equipped to handle a real emergency. And of course, when you are faced with an emergency, ChlorUp is only a phone call away through ChemCheck or Canutech. You should never feel like you're alone when responding to an emergency. So the Chlorine Institute will be sponsoring chlorine emergency response training events. And whoops, sorry, I got ahead of myself on a slide there somehow. The Chlorine Institute will be sponsoring chlorine emergency response training events in 11 cities across the U.S. and Canada in 2017. These are one-day, 8-hour, hands-on training programs that are ideal for the specialist and technician-level hazmat responders. We hope to see many of you at one of these events in the future. And if we don't see one in your area in 2017, please give us a call to see how we can help you provide training in your area. So with that, we're done. If you have any questions, you can see the www.chlorineinstitute.org website address right there, or you can send us an email at info@chlorine2.com, and we'll get back to you in writing with answers.
Thank you so much, Kevin. That was really incredible, very comprehensive, and you know, all the videos that you've included there I think were really helpful to our attendees. So we really appreciate you all putting this together for our folks today and presenting this. As a reminder to our attendees, we're not taking questions live right now, but as Kevin just said, you can visit the website for more information, chlorineinstitute.org, or send an email directly to the info@cl2.com. And questions are answered through that route. We have been recording this webinar, as we said, and so as soon as the recording is processed, we will have it up on the Shortline Safety Institute website, as well as the Shortline Regional Railroad Association website, so folks can access it there if they want to go back and watch anything that we went through today, or share it with colleagues, because this is such an important topic. So thank you again to our presenters. Thank you to the Chlorine Institute for helping coordinate all of this for us. This concludes our webinar. I encourage everyone to visit our website to look for more upcoming topics on hazmat, as well as a range of other topics. So thanks everyone, and have a great day. Thank you, Kevin.
Bye.